All right, hello there. Welcome to lesson 2 on your advanced math lesson. Today's lesson is fun. We're going to talk more about area, so like area of rectangles, areas of triangles, so you know that already. And then we're going to talk about cylinders and prisms and what those are, so that is fun. And then I have some fun mnemonics to go over for cones, pyramids, and spheres. So we're going to learn this awesome information, like all of these formulas, so that you can figure out the volume and surface area of all of these different shapes. All right, but before we jump in, did you know, fun fact of the day, that 90% of bald people still own a comb? Yeah, they just can't part with it. They can't part with it. Let's jump right in. On the left here, we have a rectangle. It has 90-degree angles here. And the length of it is going to be 3 centimeters or 3 squares. And then the height is 2 centimeters or 2 squares, 2 units basically. So it can be divided up. And this would be 1 square unit, 2 square units, 3, 4, 5, 6 square units. And we get that when we multiply 2 times 3. Area is the length times the width. This is the area, length times the width. That's the formula. This one you need to have tucked away in your memories. I mean, you just got to know this one because it's used so often. This would be the length, 3. This would be the width, 2. And 3 times 2 is 6, and that's how you get the 6 square units. Now let's move on to the area of a triangle. Now you remember the formula. The formula is area is 1/2 the base times the height. And look at this. We just learned the area of a rectangle. We've got a rectangle here. But if we divide that rectangle in half by putting a line down the middle of it, you end up with 2 triangles. And it makes sense if you think about it. Think about this as like a piece of paper. And what if you folded it right along that line? And if the area of the whole rectangle is the length times the width, in this case, that's going to be equal to the base times the height. Or I should just write BH. And if you want the area of half of that, or the area of a triangle, it's 1/2 the base times the height. Okay, the thing that gets people to get wrong answers on some of these questions is that they don't remember that the height is actually the distance from a perpendicular line from the base to the other point. And you can actually pick any side as your base. So for example, look at this triangle over here. If this is the base, then you have to pick this line, which is 90 degrees, from that base to the other point, and that's your height. So sometimes they might tell you, or you might know the area of one of these triangles, and they might ask you to figure out the area of this other triangle, or they might tell you the area of the whole triangle, and then you have to figure out one or the other. So there's a lot of ways they could make these questions kind of tricky. This picture, what they're saying is if we choose side B, look at this triangle over here, if we choose side B as the base in the triangle, you see that the height is going to be from this point down to an extension. You have to kind of extend the line, and this would be the height. This is where people get mixed up, so remember that that's going to be the height. Your base is still this part. It doesn't include that extra piece. It's more like a triangle that looks like this. See, this would have the same area as this, as long as B is the same as B and H is the same as H. Does that make sense? Okay, but this area would be bigger because you've got that extra, extra D there. Tell me if that makes sense. But if for some reason they made you figure out the area of this whole thing, you could still figure out the area of this guy. You would just have to subtract out the area of this guy. Cylinders and prisms. Okay, so what's a cylinder? I picture like a soup can, something like that. So think of that when you think of a cylinder. And the way that you make a cylinder is you start out with a line like this. Just look at that, a mathematical line. You also have a curved path, and the curved path is called the directrix. And that's like this circle, which is the bottom of the soup can. And let's say you take this line, which is kind of like a pencil, and you rub it all the way around. And that imaginary plane that you made all the way around, that's your soup can. And you made it with a pencil, a line, and a circle, the directrix. Directrix? Because there's that extra R there. Directrix. If the directrix goes all the way around and it connects on the other side, then it's a closed curve. That's a soup can. Only go halfway and you're trying to figure out, the surface area for just this halfway part, then it's open because you didn't close the circle. So it can be an open or closed cylinder. There are two parallel planes on a cylinder. Where do you think the parallel planes are on a cylinder? Okay, it's this. Like if you laid a piece of paper flat on the top of the soup can, it would be that one. And if you laid a piece of paper flat on the table and put the soup can on top of it, it would be that plane. If the paper was perfectly stiff, they would never touch, right? Because they're parallel. A cylinder is a geometric solid determined by two parallel planes, I'm drawing them out for you, that intersect all the elements of a closed cylindrical surface. It's a soup can, basically. Ends of the cylinder they have a name, and it's called a base. Okay, and the bottom one is also a base. Okay, the bases of a cylinder are congruent. That means they're identical. So if you figure out the area of this base, all you have to do is double it, and you've got the area of the bottom base. Even when it looks like this, they're still going to be congruent. Cool, that's good to know. That's useful. That'll save you some time, right? If the base is perpendicular to this, then it's a right solid. See the word right there? If it's like this, no, that's not a 90-degree angle. One is called oblique because the base is not perpendicular to the sides. What if the base of the cylinder is a polygon? So what if it's not a circle? What if it's a polygon? Then you have what's called a prism. These are like the beautiful crystals that make rainbows, like on Pollyanna, a prism. This is what they look like. The bottom is not a circle, but it's a triangle. Now it's a prism. This is a right triangular cylinder or prism. This one's a rectangle, right rectangular cylinder or prism. What does it mean, right? These are 90-degree angles. This is also a right cylinder, but it doesn't really have a specific, the bottom is just a weird polygon shape. Okay, so that's just called a right cylinder. It's right because it's still 90 degrees, like it's not slanted like the Leaning Tower of Pisa. It's straight up and down. How do you calculate the volume of a cylinder or the volume of prisms? First, I'm going to tell you what the units are going to be. Anytime you have just a straight line, the units are going to be something like centimeters. There's no exponent. Anytime you have an area, now instead of a straight line, you have like a tabletop. The units are going to be in centimeters squared. Once you start making that into the shape of a cup, okay, and then you fill that with water or something, now you're adding an extra dimension. So instead of centimeters squared, it's going to be centimeters cubed. So anytime you're talking about volume and something in 3 dimensions, then the units are going to be in centimeters cubed or something cubed. It could be meters cubed. It could be feet cubed. I always have to calculate volume of medicine that I give people. So it is important. So how do you calculate? Now that we know what the units are going to be, the units are going to be in something cubed. To calculate the volume or how much soup can fill a soup can, you need to know the area of the base, so the area of the bottom of the soup can, and just one of them, the area of the base times the height of the soup can. And remember that height, just like a triangle, it has to be the perpendicular distance between the bases. So if you've got a Leaning Tower of Pisa soup can, you're going to have to use only the up and down height. Nice thing is that formula works for all cylinders. It doesn't matter if it's a triangle at the bottom, a rectangle, or some weird shape. As long as you know the area of that bottom piece and you know how tall it is, you can figure out the volume. you can always figure out how much soup is going to fill that soup can. So that's pretty cool. Remember, it's the up and down distance, perpendicular distance, not the slanty line. Don't use the slanty line. Use only the up and down distance. Okay, and it turns out that if the perpendicular distance is 10 meters for all of these, let's say we're calculating the volume of all of these. Oh, 10 meters, they're bigger than they look. That's taller than us. And the area of each base is 9 meters squared. Then the volume of each cylinder is going to be what? The volume is the area times the height. So it's going to be area is, they told us, is 9 meters squared times the height, which is 10 meters. And the answer is 90 meters cubed because you've got meter squared here plus another meter. You end up with 90 meters cubed. Because it's so easy, we are going to move right along. Lateral surface area. The next type of questions they're going to ask you when they're looking at cylinders or prisms is, how much wrapping paper do you need to wrap up that soup can? And there is a formula that you can use to figure that out. And the formula is easy. Okay? Pretend you take this soup can and you tilt it towards you. So you're looking down at the top of the soup can, at that circle. You need to know the perimeter of the base. Do you remember what the perimeter is? It's the distance, if you're a tiny little ant, that it takes to walk around the whole rim, the rim of that. It's the distance of the perimeter times how tall the soup can is. That is going to give you the lateral surface area. Remember that the height has to be the up and down distance between the bases. If it's slanty, you don't use the slanty distance, you use the up and down distance only. Now there's one more thing that they're going to ask you that is going to make it tricky, and your friends are going to get this wrong, but you are not going to get this wrong. The lateral surface area only means if you're wrapping the outside of the can only on the sides. It does not include the top and bottom because the part that says lateral refers to only the lateral walls. Now, that would work if you're wrapping a soup can and you don't want them to know what type of soup, but it's okay for them to know it's a soup can because you would still be able to see the top and you would still be able to see the bottom. But if you want to completely wrap it, you're asking for total surface area, like wrap the whole can. So if it's lateral surface area, they just want a label, a new label for that soup can. But if it's total surface area, they want to cover every square inch of that. Okay, so be careful. You have to pay attention to what they're asking you. So for example, let's do example 2.1. And if you're following along, this is on page 17 of your book, okay? It gives you this shape. This is a funny shaped soup can because it's kind of like an arch or something. Base of a right cylinder, 10 centimeters high. So that's important to know. That's this distance. The height is 10 centimeters. So I'm going to write that down because I know that. Find the surface area of the right cylinder. And since they said surface area, they didn't just say lateral surface area. They want all of the surface area. So they want to wrap that puppy, including the top and including the bottom, which we cannot see there. You can just use the equation for lateral surface area, and then you can just figure out the area of the top and multiply that by 2 because there's a top and a bottom, and just add that to whatever you get for lateral surface area. The area of the top piece, that's easy. So what's the area of the square? Let's do that first. That's a rectangle. Area is length times width, easy peasy. So it's going to be 5 times 6. And we're talking about units of centimeters. So 5 times 6 is going to be 30 centimeters squared. Okay, now let's go back and calculate the area of this semicircle. And it tells us that the radius of that circle is 3. But if it were a circle, it would go all the way around like that. Let's calculate the area of a circle. Pi r squared is pi, and then r is going to be 3 squared. So it's 3 times 3 is 9. It's 9 pi, and it would be units of centimeters squared. However, it's not 9 pi because this is only half of a circle, not the whole circle. So I have to make that 9 over 2 pi. Okay, now I add these things up. If you do the math on that, just add that up. 44.1 centimeters squared. What did we just calculate? Always ask yourself that. What did we just calculate? That's the area of the top only. Now I have to multiply that by 2 to make it the top and the bottom. So now it's 88.2 centimeters squared. Now I still need the lateral surface area to add to that. What is the lateral surface area? Remember, the lateral surface area of any right cylinder is the perimeter of a base times the height. So the perimeter of the base. Let's go back to the picture and look at perimeter. You're a tiny little ant. You start here and you walk all the way around. Okay, so it's going to be 6 plus 5 plus, this part is tricky, plus another 5. So it's 6 plus 5 plus 5 plus a tricky part. What is this tricky part? It's going to be the circumference of a circle divided by half. Because you don't walk around the whole circle, you only walk around half of it. What is the circumference of a circle? The circumference is 2 pi r. And we know that r is 3. So I'm going to plug that in. 2 pi 3. So it's 6 pi. But remember, we only walked around half the circle. We didn't walk around the whole circle. So it's that divided in half. So now it's just back to 3 pi. And so what's the total distance that little ant walked? It's 6 plus 5 plus 5 plus this part, which is 3 pi. And if you add all of that together, 25 centimeters. Okay. So that is the perimeter. So let me write the formula. I don't want to get confused on what we're doing. Just figured out the perimeter was 25. Multiply that by the height, which is 10 centimeters, and you get 250 centimeters squared. Okay, so the lateral surface area is 250. Then I'm going to add that to my 88 that I got before for the top and the bottom. And then I have the total surface area, which turns out to be 342, something like that. And what are the units? Centimeters squared, because it's an area. Let's go to example 2.2. This is going to look complicated, but I promise it is not that complicated. They want you to find the total surface area of this. Like if you had to wrap that in wrapping paper, how much wrapping paper would you need without any overlap? Whew, that is tricky. All you have to do is find the lateral surface area of this part, all of this shaded part. That's going to be the lateral surface area. And then you need to find the area of the base and multiply that by 2 because there's one just like that on the other side. Perimeter times the height. So that's just the lateral surface area. Let's calculate the perimeter. If you were a little ant, you go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Let's just call it units. 24 units times the height. The height is going to be 6 units. So 24 times 6 would be 144. So units squared. Okay, so we've found the lateral surface area so far. Now we need to find the area of the base. This is easier than it seems because let's look at the base. You can actually think of it as a bunch of squares, a bunch of 2 by 2 squares. So what's the area of one square? It's 2 times 2, length times the width, which is 4 square units. So this is 4 plus another 4. It's going to be 8 plus another 4 is 12, another 4 is 16, another 4 is 20. 20 square units. So that's the area of a base, plus another 20 for the other side. Don't forget the other side. And if you do the math there, 184 square units. And that's the answer. Bam, we did it. You probably got to that answer before I did because you were faster at that. All right, let's move on to cones and pyramids. This is where it gets fun. Okay, because look at this. We started out with an area. This is the length. This is the width. 6 times 4. This is like a tablecloth. What's the area? It's 6 times 4, 24 square units. Easy. Now, what if you want a volume? You want to pour water into that cube. What do? We have this 6. We have this 4. The area of this is 24. But now we multiply it by the height, which is 5. You get a volume of 120 cubic units. Okay, but what if you've got this same base, a 6 and a 4. Here's your tablecloth right there, 6 and a 4. But instead of making a rectangle, you make a pyramid. So you just have one point. That point connects to every corner of that base. And you want to fill that with water. What's the volume that it'll fill? Turns out that it's a third of what it would be if you had made a box. So if you had made a box, it's now a third of that. Kind of picture like this shape, but now it's like one here and another one here. And you can see how, yeah, it would be about a third of if you made it a rectangle. Here's the formula that you need to memorize. The volume of a cone is 1/3 the area of the base times the height. So the way I'm going to remember that is if it's a cone, it's kind of like an ice cream cone, and you have 3 scoops of ice cream on top. So you have to remember that there's now a number 3 in there. And the volume of a cone is 1/3 times the area of the base times the height. What if we made this horribly complicated? And you start out with a base that looks like this. It almost looks like you tried to make a heart, but it turned out dumb. You could calculate the volume of that whole shape by figuring out the area of this area and then knowing the height. You would have to know the area of this triangle. I won't go through it. Half the area of this entire circle. This, pretend it's a circle, but just half of it. And then the area, 1/2 the base times height of this triangle too. And then you just add those together, multiply it by the height, and then you get this. But if it's, instead of being a cylinder like that, it's a cone, then it's going to be down to 1/3 of the size. Okay, cool. So that's how it works basically. Let's do an example. It's not going to be as complicated as that. The base of a cone is shown. So here's the base of a cone. The dimensions are in meters. If the cone is 6 meters high, okay, so that's the height. What is the volume? So we remember the formula. The volume is going to be the area of the base times the height times, because it's a cone now, 1/3. It doesn't have to be in the same order as the formula. Commutative property of multiplication, it doesn't matter the order. You can put the 1/3 at the end. It's the area of this rectangle, which is 2 times 3, which is 6, plus the area of pi r squared, but only half of it. And then r is going to be 1. So I'm going to erase that r and put the number 1. 1 squared is just 1. So it's just half of pi. Just to write it out, 6 meters squared plus 1/2 pi meters squared. You get 7.57 meters squared. That's the area of the base. That's all we've done so far. Multiply that by the height. They told us it's 6. And I'm also going to remember to multiply it by that 1/3. I just plug all of that into my calculator and I get 15.14 meters cubed. The units are important. Okay, now let's look at a cone, but this time they don't want to know the volume of the cone. They want to know the surface area. What if you had to wrap that cone in wrapping paper? How much wrapping paper would it take? The formula that you need to know is lateral surface area of a cone. Remember, it's not the base, it's just going to be that lateral surface area, is pi times r times L. And the way I remember that is pi is pi. What if I spelled it out? Instead of having that pi, what if I spelled it out? It looks like you're saying pearl, which is a bad spelling for an actual pearl. If you wanted to wrap this as a present and you wanted to know how much wrapping paper it's going to take, just think of the pearl. The pearl makes it a good present. Maybe you can wrap it in pearly white paper. So the lateral surface area of a cone is pearl, Pi times R times L. R is the radius of the circle. That's this circle right there that is the flat part of the cone. And the L is different this time. This is really important. The L is not the height. It's the slant height. So when you're talking about pearl or the lateral surface area, it's actually the slanty distance. Let me show you what the slanty distance looks like. Okay, it's not this. That's what we usually use for the height or the altitude. It's actually this line in the middle here, a slant line. And it kind of makes sense because this is the part of the edge that is important when you're wrapping it in wrapping paper. So it's actually the slant height. It's also not this edge. It's not that. It's a slant height, which is a line from the very top to a 90-degree to that edge. So it's right in the middle of any of these triangles. Okay, that's the slant height. So it's not the edge, and it's not the same as the height. And to calculate the total surface area, you're going to have to do the area of the base and add that into, and you're also going to need the area of all the faces, which is the lateral surface area. Okay, cool. Let's do an example. Hang in there. I'm just reminding you here that you should hang in there because we're not that far from being done. So please hang in there. You got this. You got this. And then I'm going to show you a trick to remember all these formulas at the very end of this. So pay lots of attention to that then, okay? This looks like kind of like a Chinese hat or something like that. It says the radius of the base of this right circular cone is 8 centimeters. So what are they talking about? This radius here. So this is a circle at the bottom. If you picture like a hat, that's a circle. So the radius here is 8 centimeters. I'm going to write that down. Slant height of the cone is 10 centimeters. So they're telling you that this is 10 centimeters, the slant height. Okay, they just want to know the surface area of the cone. So the surface area is going to be the lateral surface area plus the area of the base. Okay, the lateral surface area we just discussed is going to be pearl, which is pi times the radius times the slant height. And then we're going to do the area of the base, which is the whole circle, pi r squared. We don't need to double it because there's only one of them, right? Because it's a cone. So let's start plugging in numbers. Pi is going to be 3.14. The radius is going to be 8. The L, we're here now, is going to be this 10 centimeters. So it's the slant height. And then we're going to, this should not be a multiply. This should be a plus sign right there. So we're going to add pi r squared, which is 3.14, times the radius, which is 8, and we're going to square that. And if you do the math on all of that, you are going to end up with 144 pi centimeters squared. You don't need to, I guess you don't need to multiply out pi. You can just say that as part of your answer. Let's jump in and do the next example. This is the same type of thing, same shape, but it tells you that the volume of this guy is 6 pi centimeters cubed. Volume is 6 pi. The height of this circular cone is 2 centimeters. This is the information that they're giving us. Then they want us to find the radius of the base. What is the radius? So the radius is actually the unknown. So they're kind of giving you this problem backwards. So what is the formula for volume? You have to remember the formula for a cone. Volume is base times height times 1/3. Remember the ice cream cone? Volume is 1/3 base times the height. Now, when we substitute in the values that we know about the 1/3. We know that the total volume is 6 pi, so I'm going to put 6 pi over here. We know the base. What do we know about the base? No, we don't know the base yet. That's b, that's the unknown, the radius. But we do know the height is 2 centimeters. All we have is an equation with one unknown. The unknown is here. So if you divide both sides by 2, and then you multiply both sides by 3 so that that cancels out, you're going to get base is equal to 9 pi centimeters squared. It wants to know the radius, but we figured out the area of the base. So to get the radius, all we have to do is use the formula for area of the base is equal to pi r squared. So we got for our answer 9 pi is equal to pi r squared now. Look at that. Those pi's cancel out. So 9 is equal to r squared. Take the square root of both sides. R is equal to 3. Now we know that the radius is 3. That was a long way to do it, but I just want you to know that you can do these problems backwards, and they'll expect you to know how to do that. All right, let's jump in with this next example. They give you a regular pyramid here. See that regular pyramid? It's a square on the bottom, but it's a pyramid. And they tell you that each side measures 4 centimeters. It's 4, and this is 4. Slant height is actually 5 centimeters. And they want to know the surface area of the pyramid, area of this, plus the area of each side, each triangular side. What is the area of the base? Oh, that's easy. It's a square. So the area of the base is equal to length times width, which is 4 times 4, which is 16. Okay, so we got part of that already. Let's take one of these triangles and just look at it like this, okay? So we know that the bottom part measures 4 centimeters because that's the same as the sides of one of the squares at the bottom. The slant height is 5 centimeters. Now the slant height, I drew it in a weird way because it's not actually the edge. Remember that the slant height is not the edge. The slant height starts at the top and goes to the very middle of one of the triangles. It goes to there. That's what is actually 5 centimeters. So if you're looking at one of the faces, the slant height is actually here. It goes right to the middle, and this is 5 centimeters. That color's kind of hard to see. I hope you can see it. So if I want to find the area of one of the triangles, it's just a triangle. Area is 1/2 the base times the height. So it's 1/2, the base is 4. The height is actually the slant height, which is 5 centimeters. And when I multiply that out, I get 10 centimeters squared for the area. But remember, that's just one of the triangles. How many triangles are there? Well, if it's a square on the bottom, there has to be a triangle that meets up with each side of the square. A square has 4 sides, so it's going to be 10 times 4. I need that much wrapping paper. So I need 40 centimeters squared of wrapping paper. Don't forget the area of the base. You want to wrap that too. So we're going to add the 16 to it and get 56. We need to talk about spheres. Spheres are easy though. You got this. You got this. This is the last thing that we're going to talk about, and then we're all done with today's lesson. A sphere has to be perfectly round. It's a perfectly round 3-dimensional shape. Every single point on the sphere is the same distance from the center. So you could pick any point. If this is a basketball, any point on it. Doesn't have to be right on the edge when you're looking at it. It's the same distance from the very center. That's called the radius, the r. You want to wrap it in wrapping paper. How much wrapping paper do you need? So the formula for the surface area is 4 pi r squared. Now that's kind of hard to remember. It's the surface area of a sphere. There is a mnemonic that is supposed to help that they mention, and they say to imagine a grapefruit. And if you cut that grapefruit in half, you would have a circle that is pi r squared. If you cut it in half, the other half would look like this, but you actually need 4 pictures like this in order for you to cover the entire surface area of that grapefruit. So an easy way to figure out how much wrapping paper you need is to cut the grapefruit in half, figure out the area of one of the sides, like one of the circles when you cut it in half, and then multiply that by 4. And that's how much wrapping paper you're going to need. Okay? So I don't know if that helps you remember it, but if it does, there you go. What about volume? Okay, not volume of cylinder. We're going to talk about the volume of a sphere. But in order to talk about the volume of a sphere, they want you to imagine this. You put the sphere into a cylinder that barely covers it, like the edges are touching the edges of the cylinder. But this is the volume of a sphere. You just have to sort of memorize this equation, and this kind of thinking about it in terms of a cylinder is supposed to help you remember the equation for volume of a sphere, but I don't think it helps me. An example, 2.7. Find the surface area and the volume of a sphere if it has a radius of 9 meters. Now, they don't show us any sort of picture, so we have to use our imagination like SpongeBob. But that's okay, because we know the formulas. 4 pi r squared. It's like the grapefruit that you cut into 4 pieces. R, they tell us the radius is 9 meters, so it's 9 squared. Just do the math on that, and you will get the right answer, which is 324 pi meters squared. It's squared because it's surface area. You're talking about now we're doing volume. What's the formula for volume? It's the one that was hard for me to memorize. 4/3 pi r cubed. Don't forget that it's cubed because it's going to have to be 9 times 9 times 9. Okay? That's going to make a difference. You'll get the wrong answer if you don't cube it. 4/3 times pi times 9 times 9 times 9. We'll get 972 pi meters cubed. One more problem and we're done. Here, you've also got to have an imagination. They want to know the surface area of a sphere whose volume is this. Ooh, that's tricky because they tell you the volume. Oh, why do they tell you the volume? It's tricky. They're making you really work for it. So volume, which is equal to 288 pi, because that's what they just told you, is equal to the formula for volume. 4/3 pi r cubed. Okay, the only unknown here is r. So the reason that they told you the volume and you have to figure out the surface area is you need to use volume to go backwards, figure out what r is, and then you can use that r for the formula for surface area. Does that make sense? So now I've got this equation. It looks complicated, but check it out. The pi's cancel out because you can divide each side by pi, and that cancels out. So let's just erase the pi. That's sad. Erase the pi. If I multiply both sides by 3/4, then that cancels out. This cancels. And I have 288 times 3 divided by 4 is equal to r cubed. And then I take the cubed root. It has to be the cubed root. Do you remember how to do that? And that'll give me r. And when we solve for r, we get 6. Whew, that's tricky. That r is not what they asked for, though. They asked for the surface area. So now that I know r, I can erase all of this and write the equation for surface area. 4 pi r squared. It's just pi r squared, which is like a grapefruit, multiplied by 4. Okay, so I just plug in what I know. 4 pi, r is now 6, 6 times 6. And then I just multiply that out, and I get 144 pi. What are the units? Centimeters squared, because we're talking about surface area. Woo, we did it, Addie. Mission accomplished. I hope you enjoyed this lesson at least a little bit. You probably knew some of it. Oh, here's the trick. All of the formulas are written down. Turn to the inside cover of your book. In the inside cover of the book at the very, very back, like the very, very last page, it's actually written on the cover. It says geometric formulas. You are allowed to use that for your homework so that you don't have to memorize every single equation. All right, love you. I hope that helps. Bye.